All right. So number 2, we have what is the percent yield if you experimentally produce 3.65 grams of copper when 1.87 grams of aluminum reacts with 9.65 grams of copper 2 sulfate. It's a lot of numbers right here, right? Okay, first things first. 2 things. Stick with what we know. We need what? Chemical reaction and limiting reactant. Okay, do I have a reaction here? Yes, but is it balanced though? No. Okay, how many Al is here?
1.
And how many is here?
2.
So how many should I have?
2.
And where do I put the 2? Which one?
The first one.
Huh?
No, the first one.
Good. My aluminums are balanced?
Yeah.
Okay. What's next? Yeah, so SO4. How many SO4s are right there? 1. 1 SO4. And how many are here? 3. So how can I balance that? Perfect. Okay? And then that changes my copper to what? 3. So I put a 3 over here. You're with me? Okay, everyone agrees on that. All right. So in the question, I have 3 numbers. Let's digest what all of these numbers mean. What is the percent yield if I experimentally produce 3.65 grams of copper? What is copper? A reactant or a product?
A product.
Product. And what is the question asking me? What is the percent yield of that? So what does this number mean then, this 365? Good. So if we remind ourselves of the formula, actual over theoretical times 100. Okay? I am always given which one? So if I'm experimentally producing that number of copper, where do I put it in the fraction? Good. That's 3.65 grams of Cu. That's my actual. What am I looking for? The theoretical. Again, grams of what here I'm looking for? Copper. You're with me? Okay. You can see, right? It's not too small? Okay. So, what are the other numbers I get? I get 1.87 grams of aluminum and 9.65 grams of copper sulfate. And what happens between those 2 things? So what are they? Reactants. Okay, I have 1.87 grams of aluminum and 9.65 grams of copper 2 sulfate. So look at that. I'm given grams of both of these reactants. So we said we need 2 things. We need our reaction, which we have, and now we need our limiting. Okay, does it give me any idea of what the limiting is? I mean, no. It doesn't tell me who's the excess, so I don't know. It doesn't give me only one number. Remember, last problem it only gave me one number, so I only used the one number. Here it gives me 2 numbers. So I got to determine what the limiting is with those 2 numbers. So what I'm going to do is I'm going to take both of those gram amounts and convert them to what? Moles. Read the reaction with me in terms of moles. I need 2 moles of reacting with copper sulfate to produce and Al. Perfect. Okay, so I am in need of 2 moles of aluminum for the reaction and 3 moles of copper sulfate. I got to convert these to moles. Are you with me? So that I can see, compare it, and see if I have enough. So I will convert both of these numbers to moles. Okay? So, what goes on the top of the fraction? Right, what unit? Good, moles, because I'm looking for moles. And the bottom is? So this is molar mass, and that's why I put 1 for the mole. Good. And what's grams of aluminum? How much does aluminum weigh? 26.98. Al. How about the molar mass for copper sulfate? Cu is what? I think it's... Good. Plus 32.07 plus 64. 159.62 grams of my molar mass. Perfect. Okay, now I have to divide. What's the aluminum moles I get? 0.069, full number. 4 numbers. 466. I don't remember what it was. I think it's like 1.3? 3.1. Moles of what? Aluminum. And how many moles of copper am I getting?
0.0604.
Perfect. Moles of copper sulfate. Okay, now that I have the moles, what can I do? Good. Biggest by smallest. Who's the biggest? Aluminum moles are biggest, and then this guy's smallest. So I'm just going to put a bar in between. You get what I mean by that? I'm dividing them. Okay? When I divide them, what do I get? Big by small. Right, Marcelo? Okay. 1.147 moles of what on top? And the bottom is 1 mole of copper sulfate. The bottom will always be 1. Does that make sense?
Yeah.
Okay, now we're going to take our moles and compare it to the moles that we need. So I'm going to change the grams that I have here. Okay, so I have 1.147 of aluminum and 1 mole of copper sulfate. Correct? You're with me? So, I need how many aluminum? How many do I have, though?
1.1.
Do I have enough? No. I need, for copper sulfate, 3, but I have, do I have enough? Wait a minute, I don't have enough of either of them. Remember that trick I taught you in the last problem? If they're both under, there's a different way to tell the limiting. Yeah, so the one that's like farthest away from the goal is the limiting. So to get from this many moles to what we need, what's the difference? Like 0.8. And then what from how much we have to how much we need is 2. This is more of a difference, right? So if it's more of a difference, that one is our limiting. That make sense? So if that's our limiting, what's our excess? Good. Now, for example, what if I told you this was a 4? How would I, good, so how would I do this? Hold on. I need 2 aluminum, but I have 1.1. I need 3 copper sulfate, but I have 4. I have way more than enough here, correct? Yeah. So if I have more than what I need, this one would actually be the excess reactant, and this one would be the limiting. Limiting. You get what I mean, right? That's how it will be in the test. The second one, where 1 is more, 1 is less. Okay, but it's not like that. It's 1 for this question. So therefore, our limiting reactant is who? So this is the number I use for my calculations. The original mole number I got. Not this. You don't use that for calculations. You're with me? So I'm going to start the problem off with the amount of moles that I have for my limiting, which is 0.06045 moles of copper sulfate. And what am I looking for? Well, end goal. Good. No. What is the end goal? Good. Okay, so I'm at moles of CuSO4, so I will go to moles of Cu, moles of CuSO4 at the bottom, so it cancels out. This is mole to mole ratio, so I get that from the reaction. 3 moles of copper, and then 3 moles of copper sulfate, right? Times a fraction, moles of Cu at the bottom, grams of Cu on top. What's the molar mass?
63.55.
Per mole, correct? So can anyone tell me what the answer is? 3 point? Let me double check. Anyone else got the same? Yes. I got 3.841.
I didn't do 0.0605. I just put, I didn't
Okay,
4.
that's fine. This is what I know. These are the numbers I used. Okay, so that's moles, grams of what? Okay, and this is what?
Our theoretical.
Our theoretical. So I'm just going to like not really box it because it's not our final answer. So this is like our theoretical yield. Okay, so I'm going to take this guy number and put him where? At the bottom of the fraction, correct? Okay, so then I will put 3.841. So when you divide and times by 100, what do you end up getting?
I got 95.02.
Good. So 95.0 is 3 sig figs. That is our percent yield. Is this a good yield?
Yeah.
Yes. So here's what I'm going to do. Look at this. I'm going to like break this apart. So this pink section is finding the limiting reactant and excess reactant. The purple part is finding what? Do you know? Yes. Let me move this. For the percent yield, yes. We've always done percent in 3 sig figs. Finding the theoretical. Okay, and then the orange is good, yes. You see all the steps in different colors. Finding the percent yield. Okay? Was that helpful?
Yeah.
Okay, beautiful. Any other questions on this? So right now, what time is it?